Hi, and welcome to video writing REST controller using Spring WebFlux to perform operations on the topic. In this video, we'll start by reviewing what we've done so far. We'll briefly discuss why you'd want to use a Spring Data REST instead of writing your own, like we did in the previous videos. Then we're going to rewrite the data access service using Spring Data REST and finish the section by actually writing the WebFlux service that ultimately will serve our front end. And finally, we'll summarize what we've learned in section 1.1. So in the last two videos, we created a simple Helios service that wraps our database repositories blocking code. For this, we had to develop our own repository extension, which included some relatively advanced coding with generics and introspection. But to really have a fully functional JPA wrapper that includes our advanced features such as relationships and auto discovery, we would have to write a lot more code than we have done up to this point. So fortunately for us, the folks at the Spring Data project have already created such a fully featured Helios REST service that uses the Hypertext Application Language, or HAL for short, which basically exposes all the nice features of JPA and Hibernate, such as relationships and other advanced features. So let's dive into the code. We'll start by using the Spring Initializer, and to differentiate it from the other one, we'll call this one Data REST, and we've pre-selected REST repositories and DevTools. We'll also go ahead and create the actual service, the WebFlux service, and we'll choose Reactive Web for this one. So this is our original data service project. We've also opened the new data REST, which is basically empty right now, and we've also opened the WebFlux service, which we also created with the initializer. So let's go ahead and copy the configuration that we had for the previous data service. So we have all the dependencies that we need for reverse engineering and the Gradle plugin for Hibernate tools. We'll copy the application properties file as well. So at this point, our HBM to Java should run. Here's the new project data REST alongside our old data service. Okay, and that worked out perfectly. If we go back to our IDE, we should see the Java classes and the Hibernate configuration files, and we'll see our topic class generated from the database. So we'll go ahead and create a topic repository. But this time we're going to annotate it with a different repository tag called repository REST resource. And we're going to extend this from paging and sorting. The paging and sorting repository with topic and long for the ID. We'll also show you how to create a configuration class so you can tailor certain aspects of the way that REST is going to operate. Here we're going to add two typical configuration parameters. Suppose ID. We have to do this for each class. So this property will make sure that when we return the objects, we're going to return the ID filled in. Else it will be null. And in this case, we want to make sure that when we post and put, we return the body instead of just the location header. At this point, we can actually run the default test just to test that our application will load properly, will load all the context to Hibernate and be able to connect. We just do this. We should be able to run this right within our IDE. and it passes perfectly. So now what we can do is copy the test that we had defined for our previous application, and they should run here without much change. So we'll ignore this one for now because there's a slight change of API. The default Hadios implementation with HAL uses a different search method. The rest of the test should work with minor adjustments. We have to change some URLs that are different. This one will work. On this one, we need to change to a plural, and also for the patch, as well as to get topic. This is because the semantics in Spring Data REST are a bit different than the semantics that we had implemented in our own custom ADOs web service. So at this point, we can test each one of these individually, post test, for example, and it should be working. So same exact test from the previous application passes here as well. Or we can run all the tests that we have so far just by running the test file, and they all pass. Now there's something very interesting about this service. On the surface, it looks the same, but if we look at the detail, you'll see that it's a lot different from our custom service. Okay, so you see our Tomcat started on port 8080. And in this case, we're not going to give it a URL and see what the auto discovery is about. And you see in this case, this data service is much smarter than the one we wrote. It's telling us that at this level, we have some available resources, one of them called topics at this link, and we can actually page size or sort them, and also gives us a profiler. So we can actually follow this link, and we get all of our topics, including the long ones, all the topics we have in our database. Or you can do topic 1. And here's where the HAL starts adding value. If we had relationships to this object, we'll see them here, and that's very powerful. So now we have this working, let's create the WebFlux consumer. So we're going to add the reverse engineering plugin here as well. Nevertheless, this WebFlux project won't have any JPA, JDBC, or anything like that. It will only have the classes that we're going to reverse engineer from the database. In this case, we're only pulling in specifically persistence API so that the code is able to understand the domain object, and we're only going to need the MySQL connector for the HBM to Java. Let's make sure our HBM to Java is working. So now we're going to create the service layer, which is basically the web client who's going to consume our data service. So that's all there really is in terms of the web client. In this case, you will notice the mono type. For the stack to be completely reactive, every return type needs to be either mono for a single object or flux for a collection. So as long as every layer returns mono or flux, then the whole stack will remain reactive and will use the reactor underlying libraries. So now let's create the controller. we're going to use the annotation-based WebFlux instead of the functional. So we're going to go ahead and auto-wire our data service and just implement a controller like any other Spring controller. Well, and that's basically it. You'll notice that the return type for the controller is also monotopic. Same old Spring controller. So at this point, we would like to run our context load just to make sure that our application is working. Okay, perfect. And there's one more thing we need to do, which is make this one run on a different port, in this case, port 8081. We just edit our application properties and add the property there. And that's it. Let's go and test it. Okay, so now we're going to run it. So now you notice it loads a lot faster. And instead of Tomcat is Netty, which is a bit better adapted for reactive streams. And it's running on port 8081. So if we try curl, should get a 404 because there's nothing on the path root, right? But if we try topic 1, then we get our topic, and you see the response time is instantaneous. So that's basically all there is to it. In terms of WebFlux, you see the application is very simple. In the next section, we will be adjusting this WebFlux service to the specific semantics that we want to expose to our front-end application. But for now, this marks the end of video 1.6 and also the end of section 1.1. To summarize what we've learned in this section, we had a general introduction to Spring and Spring 5. We learned how to set up a Spring Boot project with Gradle. We worked with Spring components, controller, service, repository, and others. We've done some Hibernate reverse engineering. We've written JPA repositories and repository extensions with advanced topics such as generics, introspection, and aspects. We've seen details of Spring 5 Web MVC and Spring 5 Data REST. We've seen how to develop a basic WebFlux service, and we've done all this using test-driven development. In the next section, we'll develop the front end of the search application.